Hi, this is Sanjana T, working as Assistant Professor in Department of Electronics and Communication, BMS College of Engineering. Today in this video, we will be learning how to use Microwind tool to build layout of inverter and simulate the same. Go to Microwind website and then go to setup packages and download 3.5. You would be only be able to download it once you have given signed up. So once you sign up and create registration, so particular to a particular PC, you will get a trial pack of Microwind 3.5 Lite or 3.8 depending on the system specifications. Go to file and select Foundry. So this indicates 0.6 micrometer is the 2 lambda. Here it's 0.08. Here it's 0.8 micrometer. Here it's 0.012 micrometer. So if you open this, you get the lambda as 0.06 micrometer. So these are the values of 2 lambda and this is the value of lambda. You can check it out by going to ruler option, which is there here. So now if I click on this and measure in this way, I'll get the spacing between two dots is 0.06 micrometer. Once you go to help and go to design rules, you get all the specifications here, like what should be the spacing between two PMOS or two NMOS whenever you place the components, and once you're connecting them using metal layers and polysilicon, what should be the width of that, what should be the spacing between them. So all these are specified here. If you press this one, which is palette, you get here in this window different options of you have metal 1, 2, 3, 4, 5, 6. All these are different metal layers for connections. And then you have polysilicon, it's used for the gate connection. And then you have contact in order to connect between two layers. And you have two kinds of polysilicon once again, and you have P plus diffusion for PMOS. So suppose you draw a rectangle in this way. Here you can choose this rectangle option. Suppose you want to construct a PMOS, then draw in this way and use a ruler, measure this and make sure that the width of the PMOS is as per the specifications. And once you need the gate, then you can give the polysilicon in this way. And if I want to move it, I use this option. I select and then I'll move it. So one end is the source, the other one is the drain, and you can create anvil as well around this PMOS. You need an anvil, so this is an anvil. And then how to construct an NMOS, you can click on N plus diffusion here, click on this, and after that again a polysilicon for the gate. So I'm just doing it in a rough way. So this is source, this is drain. You have to construct the NMOS with proper width and length, looking into the design rules which are there in the help. So in this way, you can construct PMOS and NMOS manually, and you can do it in this way. Or else you have an option here, you can see, of NMOS and PMOS. Click on this MOS generator. So here you are getting MOS parameters, width and length. You can see here we chose in the Foundry 0.12 micrometer, and the width is 0.6 micrometer. So the length is fixed to 2 lambda, You can choose NMOS or PMOS. We are constructing a inverter, so choose PMOS and give generate device. Place it. I'll just zoom out so that you can view it properly. So this is a PMOS. And what else you need for an inverter is NMOS. So let's choose again MOS generator and click on NMOS. And you can change the width and the length, but for this we are not changing. And click on generate device and place it. So we'll move it a little down. So click on move option, which is here. Select the NMOS and let's move it exactly below the PMOS. Okay. So once you have done it, we know how is the schematic of an inverter. You have to connect gate to gate. So choose polysilicon here and then connect these two gate to gate of PMOS and NMOS. And what we need to give to the gate is input. So choose the input as square wave. You have add clock option. So choose that. And place it on the polysilicon. Click on that. You get input. Name it as input. And we have certain rise time and fall time. It's given here. And the high level is 1.2 and the low level is 0. So let's assign this, and it should be in visible mode, visible in simulation, otherwise you don't get that waveform. Click on assign. So this is where we are giving the input. Later on, where we are taking the output is at the drain. So take metal 1 layer and connect the drain of PMOS and NMOS. This is where we are seeing the output. So click on this option, visible node, and then click on the connection that we have done here. And give it as output. Give assign. What else is that we need to connect VDD to the source of PMOS. So choose here this option, VDD supply. Click on that and click on this. So I'll show once again. So click on this VDD supply and click on this contact. So VDD is connected to the source of PMOS, and the N-well is surrounding this PMOS. So N-well, the bulk of the PMOS should also be connected to VDD. So click on VDD and connect it here. Coming to NMOS, NMOS has P as the substrate. So by default we have in the IC P substrate, and that is connected to the lowest supply voltage. So here we are concerned only with connecting source of the NMOS also to ground. So we have ground option of ground here. Take that and connect it. So once you have done with all the connections for the inverter, let's analyze this. Go to analysis and first do design rule check. So here you can see in the bottom corner that you have no design rule error. Okay, so in case you have design rule error, then the error will be displayed and it will be highlighted in the layout, so that you can go there and you can correct the error. So once you are sure that the layout that you have done is according to the design rules, then you can go with simulation. So here we have an option of run simulation. So if you click on this, you can see the output waveform. So if you want to view both input and output together, then input also, go to input, double click on that, then you should give a visible in simulation window and you have to give assign. And then we'll rerun this. So here we are getting inverter output. You can see for the high pulse we are getting a low pulse, for positive half cycle you are getting negative half cycle. So you are basically getting inverter input output waveform. So this is how you can do the inverter layout. You can either go to palette and take NMOS and PMOS which are readily there, and you can generate the device with whatever you need as a width and length. You can choose that. Remember that the length cannot exceed the 2 lambda which you have chosen from the foundry, but then the width can be varied. The width can be varied according to your specifications. You can either generate PMOS and NMOS from this option of MOS generation, or else you can manually